Hello everyone, my name is Ben. Welcome to my C programming language tutorial. Okay guys, I don't want this video to be very long, but if you guys could remember, whenever I come live I talk about hacking a lot, okay? And I told you guys that one of the reason why people applications are vulnerable is because they don't know what function to use that will make their program to be protected. Alright, so in this video I'm gonna give you a real example on how buffer overflow is generated and how to avoid it. Okay, but before I go straight into what this video is all about, make sure you give me a like, follow me, and also share this video. And remember, I will be going live today by 8 p.m. Alright, so let's go straight to what this video is all about. So we are going to talk about buffer overflow. So what are buffer overflow? Okay, a buffer overflow is a software vulnerability that occurs when a program writes more data to a buffer than it can hold. Okay, this causes the essence data to overwrite into an adjacent memory locations, which can corrupt data, crash the program, or even allow an attacker to execute malicious programs. All this in a nutshell simply means that when an input exceeds the buffer capacity, it overwrites adjacent memory, and this is not a good thing. That's why you see many applications and software out there are vulnerable for attack. So today I want to give you guys a practical scenario of what buffer overflow is and also how to avoid it in your application. So without further wasting of time, let's dive straight into this video, guys. So I have a directory here, a terminal here opened. So I will just change to my home and I'll make a directory and I'll call it buffer. Alright, it should be called buffer. Yeah, that spelling is wrong, but don't mind me. So buffer, I press my enter key. So ls, there is nothing in here, so it's clean. So I'm going to use vim to say vuln.c. okay, should be called vuln.c, which is vulnerable.c. so I press my enter key. So I'm going to write a simple C program that will teach us or illustrate what buffer overflow or vulnerability in applications is all about and how to avoid it. So we start writing the code in C language. Alright, so I will just include two header here that will allow me to use some functions. Alright, because buffer overflow is all about functions mistake. Programmers making use of wrong functions they are not supposed to use. So I'm still gonna define a fixed size here, and I will call it size, and I will say 10 bytes. Alright, so which means this size, when it's given to a given array, it should give it a fixed size of 10 memory allocation. Okay, then the next thing is I'm gonna write my main. Okay, my main. In the main I'm not passing anything, so I will leave it empty. Then the next is return 0 semicolon close curly brace. So here I'm going to create a character of array, so I'll call this buff. Alright, so this buff should take a fixed size of the size defined above. Alright, so at the end I put my semicolon. So this size defined above here, alright, this size here defined above here will be the size of this sharp in the memory. So I press my enter key. So the next thing is that I'm going to use a function called string copy. Then I will pass in the buff, comma, and the size of string we want to read into that buff. So I will say thanks guys for watching. Okay, and that is it. And that is it. So the next thing here is I will use a printf function, okay, to print the string to the screen. Alright, so I will just pass in here buff and I will close it, and that's all. So this program now is vulnerable. So let me explain how vulnerable it is. Now this string here called string copy makes this program vulnerable, which means you should avoid using it. How does this strcpy make this program vulnerable? One is that, first of all, we have a fixed size of array here, which is 10 bytes, which is this 10 bytes here, and we are passing buff here into the function called buffer because we want to read a string into it. By right, the string we are reading into buff shouldn't exist the size of 10, but you see the amount of string we gave it here is above 10, and when we count it here, okay, thanks is 6 letter words, then the space is 7, G is 8, U is 9, and guy is 10. So this is what should be printed out. Thanks guy. So the other space and for washing should not be printed out because they are now above the fixed size of the buff. Alright, so this is where buffer overflow comes in. Because of this function does not allow us to give a fixed size of how many bytes we are reading into a memory. Alright, so hackers love this a lot. When you use this function, they like it. They can make use of that memory space. Okay, that mistake you made using this string function. Okay, they can make use of it to write a program that is malicious, overwrite a memory content, and do so many kind of things to your application. Maybe crash the application, steal data, and so on and so forth. So for us to see that this program is vulnerable, it's gonna print thanks guys for washing instead of printing only thanks guys. Thanks guy. It's gonna print thanks guy for washing, and that is where the vulnerability comes in. So let us see. Now I will go compile this program. Okay, the compiler will complain when we are compiling though, but in some machine, if you're using old machine, it's not gonna complain. So I will just use gcc, alright, and the name of the program called von.c-von. So I'll take off the .c, I'll press enter. Now you see it compiles. Even though we have error here, it compiles. But look at the error we are talking about. You see built-in memory copying 25 bytes into a region of size. Look at it here. Look at what I'm reading. You see, this is the buffer overflow. Now you see built-in. Let me start from here, guys. You see warning. Look at it, warning. This place that I just highlighted. All right. You see warning. Okay. You see warning. Built-in memory copying 25 bytes into a region of size 10 buffer overflow. The destination. Now it's trying to tell us where the buffer overflow is coming in. Are you seeing it? Overflow. Are you guys seeing it? So it's giving us the URL where we can also check that and see that it is a vulnerable application. But if you look at here, the same thing, say destination object buff is of size 10 and we are reading bytes that is more than 10, which is 25 bytes. But when we look at this program, if I clear this, if I do ls, the program compiles. Now look, we have von executable binary, which means, let me clear the screen to make things neat. If I run von, the application will run, okay, but with some stack crashes. So I press enter, you can see we have thanks guy for washing. Look at it, 25 bytes. Why? What we give to is 10 bytes, but we have 25 bytes printed on the screen. That is what we call buffer overflow. This is what we call vulnerability. Now you can see what the stack is saying here. Now it say smash detected, stack smash detected. Why is it in smash? Because we have a function called main. All right, so how can we fix this problem so that we don't encounter buffer overflow? Now we are going to rewrite this same application not to encounter buffer overflow. So we are going to change that string copy to another function. So let's do it. So I'll use vim to open von.c this time around, and I press enter. I for insertion key. I will just come here and change only one line. So instead of string copy, I will do string n copy. Then at the end, string n copy will allow us to pass in the fixed size of that memory location. So I want to pass in this size, which is what is passed in this buff. That is the fixed size of the buff. Okay, you can see it, and what is passed in here. All right, so now let's go compile. All right, escape wq, then we compile the same code using that same compilation. Press enter. You see, no errors, everything is clean. ls, we have von executable binary, then I do ./von, and we have our output. Thanks guys. There is no thanks for washing. There is no for washing. It's just thanks guys. Why? Because we gave the appropriate size. If I go back to the program, okay, and I change the size here to become let me say 15, I'm gonna read only 15 bytes. Just watch. We recompile again, it works. Run again. You see, thanks guys for there is no washing. This is what we call writing clean program and writing a non-variable program. Now this program is not variable for attack. No attacker can get in. No attacker can get into this application. So guys, take note on this, on how you make mistakes to write a vulnerable application or software. I hope you guys love this video. If you love this video, give me a like, share the video, and come on live today by 8 p.m. to join my live so that we'll talk more about this. So see you guys on my next video. Have a nice day and be blessed. Bye.